I've talked a lot about Java's support for lists and arrays. In this section, I want to revisit primitive data types and their wrapper classes. You'll see why shortly. Some object-oriented languages don't support any primitive data types at all, meaning everything is an object. But most of the more popular object-oriented languages of the day, including Java, support both primitive types and objects. Primitive types generally represent the way data is stored on an operating system. Primitives have some advantages over objects, especially as the number of elements you need to store increase. Objects take up additional memory and may require a little more processing power. We know we can create objects with primitive data types as field types, for example, and we can also return primitive types from methods. We can mix and match primitives with objects pretty easily. When we look at classes like the array list or the linked list, which we've reviewed in detail in this section, we find that these classes don't support primitive data types as a collection type. In other words, we can't do something like creating a linked list using an int primitive type. As an example, the code below won't compile. This means we can't take advantage of the great functionality that lists provide with primitive values, at least not directly. More importantly, we can't easily use primitives in some of the features we'll be learning about in the future, like generics. But Java, as you have learned, does give us wrapper classes for each primitive type, and we can go from a primitive to a wrapper, which is called boxing, or a wrapper to a primitive, which is called unboxing, with relative ease in Java. A primitive is boxed, or wrapped, in a containing class whose main data is the primitive value. Each primitive data type has a wrapper class, as shown on the list, which we've seen before. Each wrapper type boxes a specific primitive value. How do we box a primitive? Each wrapper has a static overloaded factory method, value of, which takes a primitive as an argument and returns an instance of the wrapper class. As a recap, factory methods are often used instead of the new keyword to get a new instance of a class. The code shown on this slide returns an instance of the java.lang.integer class to the boxed int variable with the value 15. We can say the code below manually boxes a primitive integer. Another manual way of boxing, which you'll see in older code, is by creating a new instance of the wrapper class using the new keyword and passing the primitive value to the constructor. See this example below? If you try this in IntelliJ with any Java version greater than JDK 9, IntelliJ will tell you that this is deprecated code, and rightly so. Deprecated code means it's outdated code and is likely to not be supported in a future version. It's been marked for deletion from the language at some point in the future. If you come across deprecated code, there is usually always a newer, better way to do what you are trying to achieve, and you should use the new way. Java's own documentation states the following about the code above. It is rarely appropriate to use this constructor. The static factory value of int is generally a better choice, as it is likely to yield significantly better space and time performance. This deprecation applies to all the constructors of the wrapper classes, not just the integer class. In truth, we rarely have to manually box primitives because Java supports something called autoboxing. Autoboxing is where Java automatically boxes a primitive type for you, hence the term autoboxing. Java makes it easy to assign a primitive to a wrapper variable as shown below. Java supports this syntax, and it's actually preferred and in my opinion easier to read as well. Underneath the covers, Java is doing the boxing. In other words, an instance of integer is created, and its value is set to 15. Allowing Java to autobox is preferred to any other method, because Java will provide the best mechanism to do it. Every wrapper class supports a method to return the primitive value it contains. This is called unboxing. In the example on this slide, I've autoboxed the integer value 15 to a variable called boxed integer. This gives us an object which is an integer wrapper class with the value of 15. To unbox this on an integer class, you can use the int value method to do it manually, which returns the boxed value, the primitive int in this case. Just like boxing, it's unnecessary to manually unbox. Automatic unboxing is really just referred to as unboxing in most cases. You can assign an instance of a wrapper class directly to a primitive variable. The code on this slide shows an example. We're assigning an object instance to a primitive variable in the second statement. This is allowed because the object instance is an integer wrapper and we're assigning it to an int primitive type variable. Again, this is the preferred way to unbox a wrapper instance. Let's get back to some code now and see different examples of orderboxing and unboxing in action. There are a lot of ways Java supports orderboxing and unboxing. I've shown you a couple of simple examples on the slides. I want to review these in code, but I want to also get you thinking about other places this feature can be used. I've created a project for this called AutoBoxing. I'll start with manual boxing and unboxing. I'm showing you these three statements so that you'll recognize a few things. The first two statements are attempting to manually box the primitive int15 to an instance integer wrapper class. Notice that IntelliJ is trying to attract our attention. Depending on your configuration of IntelliJ, either some parts or everything after the assignment operator is highlighted. In my case, you can see value of is highlighted. Hovering over the highlighted part of that first statement, IntelliJ tells us that this is unnecessary boxing. Now take a look at the second statement. IntelliJ has for me placed an error underneath the integer class, but you may find it has crossed out the integer class in addition to highlighting everything after the assignment operator. It's a warning, but won't stop the code from running. Let's see what IntelliJ has to say about that. The message we get is integer int is deprecated and marked for removal. I've discussed how that method is discouraged. We won't use it again, but you should be familiar with it in case you run across it in legacy code. Lastly, the third statement is also highlighted by IntelliJ, and this message says it's unnecessary unboxing. Remember that unboxing means you're returning the primitive value from an object. I will leave those three statements in, but I'll add the way you should write this for variable assignments. Integer autoboxed equals 15, int auto unboxed equals autoboxed. I'll print autoboxed dot get class dot get name, and same for auto unboxed. Here we have two declarations. The first assigns 15 to an integer variable. The second assigns the variable autoboxed to an int variable. Then I print out both variables' class names, attempting to use the getClass method chain to get name. Notice though that the last statement is a compiler error. You can use int variable types in many different places, but not in this way. The JVM knows auto unboxed is a primitive type and you can't use methods on primitive data types like this. I'll comment that last line out, then run this code, and hopefully no surprises. The output shows that the autoboxed variable is of type java.lang.integer. This example is a bit forced because it doesn't quite explain why you'd want to actually box or unbox a variable automatically or otherwise. Let's create a couple of methods, one that returns a double primitive type and one that returns a double wrapper instance. Private static double get double object. Return double dot value of with 100.00 as the argument. In this code, I am using the static factory method, double dot value of, just to make it clear that I'm returning an object of type double. In the second method, I want to return a double primitive value. Private static double get literal double primitive. Return 100.0, and that method is pretty simple. I'm just returning a literal decimal number because that's a Java double primitive. Going back to the main method, I'll call both these methods. Double result boxed equals get literal double primitive. Double result unboxed equals get double object. In this code, auto boxing and auto unboxing is occurring, but not by the assignment of simple variables or literals. The method get literal double primitive returns a primitive data type, but the JVM is automatically boxing it because it's being assigned to a variable of the java.lang.double class. And the same is true in reverse. The method getDoubleObject returns an object instance, but because we're assigning it directly to a primitive variable, the unboxing occurs automatically. I hope you can see how that's helpful, being able to use method results and autoboxing when you want to assign the results to variables. I'll pick up this topic in the next video because I want to walk you through some examples that relate to what we have been working on in this section. See you in the next video.